October 1941. Moscow, Kremlin. The telegram on Commissar Ivan Kovalev's desk contained numbers that meant the Soviet Union was losing the war before most battles had been fought. The German advance had destroyed or captured 65% of Soviet locomotive production capacity. Kharkov Works, which produced 400 locomotives annually, obliterated by Luftwaffe bombing. Lugansk Works 350 locomotives per year, damaged beyond immediate repair. Voroshilovgrad evacuated east ahead of Wehrmacht tanks, its machinery dismantled and scattered across the Urals. By October 1941, Soviet locomotive production had collapsed from 914 units annually to approximately 170. Without locomotives, there would be no troop movement, no supply lines, no war effort. The railway system was the circulatory system of Soviet defense, and it was hemorrhaging. Stalin's handwritten note at the telegram's bottom was characteristically direct. Request American assistance through Lend-Lease, locomotives. Kovalev understood the mathematics immediately. The Soviet Union needed 2,000 locomotives to maintain current operations and replace losses. That number assumed production would continue at reduced capacity. If the German advance continued westward, the number would double. He composed his request to the American Lend-Lease representatives carefully. Complete locomotives, operational, suitable for Soviet rail gauge of 5 feet, capable of handling Soviet coal quality, delivered as quickly as possible. 2,000 units minimum. The American response arrived within a week. Maritime engineers had reviewed the request. Their assessment was unambiguous. Impossible to ship assembled. Locomotives weighed 120 tons each. They were infrastructure, not cargo. Standard procedure required complete disassembly, crating of components, ocean transport, then reassembly at destination. That process required 8 to 12 months per locomotive, specialized tools, and trained assembly crews. The alternative, shipping assembled locomotives, violated every principle of maritime cargo handling. Top-heavy machines secured only at wheel points would shift in Atlantic storms. Ships would capsize. Insurance companies refused coverage. Naval architects called it engineering suicide. Kovalev sent a second telegram. Soviet Union could not wait 12 months per locomotive, could not spare assembly crews, could not divert trained mechanics from frontline maintenance. American locomotives must arrive complete, operational, ready to couple to freight cars immediately upon unloading. If America could not deliver assembled locomotives, the request was worthless. What Kovalev did not know was that his impossible demand had already been forwarded to the War Production Board in Washington. What he could not have anticipated was that 3 American locomotive manufacturers, Alco, Baldwin, and Lima, had convened a joint engineering conference within 48 hours of receiving the specifications. These companies had built locomotives for 80 years. They understood the technical challenges intimately. They also understood something Soviet planners did not. American engineering operated on a different principle. If the customer required the impossible, you designed a new possibility. The engineering specifications multiplied the difficulty. Soviet rail gauge was 5 feet between rails. American standard was 4 feet 8.5 inches. That difference required complete redesign of wheel assemblies, axles, and undercarriage. Soviet coal contained high sulfur and high ash content, producing less heat than American anthracite. That difference required larger fireboxes, modified grates, and increased ashpan capacity. Soviet winter reached -40 degrees Fahrenheit in operational areas. That difference required insulated steam lines, sealed bearing systems, and cold weather lubricants. Soviet maintenance facilities lacked American precision tools. That difference required standardized parts using metric measurements. The American engineers completed the design in 47 days. They called it the Russian Decapod, a 210-0 wheel configuration providing maximum tractive effort for heavy freight. The designation meant 2 leading wheels, 10 driving wheels, 0 trailing wheels. The design prioritized pulling power over speed, reliability over sophistication, maintainability over complexity. Every component was engineered for the specific conditions Soviet railways would impose. It was not an adaptation of existing American locomotives. It was a new machine designed entirely for Soviet requirements. Production was scheduled to begin January 1942. Soviet engineers, dispatched to observe American manufacturing capability, arrived at the Alco Schenectady plant expecting to see prototypes and testing. Instead, they found production lines already operational. The first locomotive was completed January 14, 1942, 63 days after design finalization. The Soviet observers filed reports to Moscow expressing confusion and skepticism. Americans worked in apparent chaos. 3 separate factories competed to produce identical locomotives. Workers were trained in weeks, not years. Women comprised significant percentages of manufacturing crews. Quality control relied on testing rather than inspection. Yet locomotives emerged from assembly lines at rates Soviet centralized planning considered impossible. By the time Soviet observer reports reached Stalin's desk, 10 locomotives were already being loaded onto Liberty ships in Philadelphia. The impossible had become routine. What remained impossible, at least according to every maritime engineer consulted, was transporting 120-ton assembled locomotives across the Atlantic without sinking the ships carrying them. But that problem was already being solved by American naval architects who had learned that impossible simply meant no one had been forced to figure it out yet. The Alco plant in Schenectady, New York, had built locomotives since 1848. Before the war, the facility produced 4 to 6 units monthly, each a semi-custom order requiring 8 months from contract to delivery. Craftsmen worked individual components through sequential stations. Boilers were hand-riveted over 14 days. Wheel assemblies were fitted and tested individually. Paint dried for a week before final inspection. This was precision manufacturing, the kind that produced machines lasting 40 years in service. In January 1942, Alco abandoned 90 years of tradition and transformed itself into something Soviet observers recognized but could not reconcile with their understanding of capitalist production. The plant became an assembly line. The conversion happened in 6 weeks. Sub-assembly stations replaced individual workstations. Boiler sections arrived prefabricated from dedicated boiler shops. Wheel sets came assembled and balanced from specialized foundries. Workers no longer built entire locomotives. They installed components. A riveter spent 8 hours riveting the same joint pattern on 40 boilers. A pipe fitter spent a week connecting identical steam lines. The work became repetitive, monotonous, and devastatingly efficient. Boiler assembly time dropped from 14 days to 4 days. Complete locomotive assembly dropped from 8 months to 30 days. By March 1942, ALCO Schenectady was producing 25 locomotives monthly, 6 times pre-war output from the same facility. The plant employed 8,400 workers in 1941. By mid-1942, employment had expanded to 12,000. Women comprised 28% of the workforce, handling tasks previously reserved for men. Training time collapsed from 6 months to 3 weeks through task specialization. A woman who had never seen a locomotive before could learn to install brake assemblies in 5 days of supervised practice. She would never learn to build an entire locomotive, but she did not need to. She needed to install brake assemblies faster and more reliably than any craftsman working alone. Henry Ford's principles, proven on automobile assembly lines, were being applied to 120-ton railway machines. Alco was not alone. Baldwin Locomotive Works in Philadelphia and Lima Locomotive Works in Ohio received identical specifications and began parallel production. The 3 companies had competed for contracts since the 19th century. That competition, which Soviet economic planners viewed as wasteful duplication, now became an accelerant. Each factory sought to outproduce its rivals. Baldwin developed modular boiler designs with bolted sections rather than welded seams, shaving 2 days off assembly time. Lima introduced automated valve testing, eliminating a bottleneck that had required skilled inspectors. Alco responded with improved sub-assembly coordination, reducing parts inventory by 15%. The innovation spread informally through worker transfers and industry publications, Competition created cooperation without requiring central planning. Production numbers documented the escalation. February 1942, 18 locomotives total across all three factories. June 1942, 43 total. December 1942, 67 total. Peak production came in March 1943, when the three factories collectively produced 89 locomotives, one complete unit every 10 hours around the clock. Cost per locomotive decreased as production volume increased. Initial units cost $140,000 each. By 1944, economies of scale had reduced the price to $115,000 per unit despite wartime inflation. The mathematics were brutal and clear. Three competing factories produced more locomotives than Soviet centralized planning could achieve with equivalent resources. Each locomotive required 85 tons of steel. 2,000 locomotives meant 170,000 tons of steel, equivalent to 12 Liberty ships worth of material. Steel allocation required War Production Board approval. Locomotives competed with tanks, ships, and aircraft for the same finite supply. The board prioritized based on strategic impact calculations. Locomotives won allocation because they multiplied the effectiveness of every other weapon system. A tank without fuel was a sculpture. A soldier without ammunition was a refugee. Locomotives moved fuel and ammunition. Copper presented similar constraints. Each locomotive required 2,400 pounds of copper for wiring, piping, and firebox construction. That copper could have built artillery shells or electrical systems for bombers. The War Production Board allocated it to locomotives. The supply chain supporting locomotive production involved 847 different suppliers across 17 states. Rivets came from Pennsylvania, valve assemblies from Ohio, brake systems from Michigan, boiler tubes from Illinois. Each supplier maintained production schedules synchronized with final assembly timelines. A delayed valve shipment idled assembly lines. A defective brake system batch required rapid replacement. The coordination happened without central authority through contracts, communication, and mutual interest in maintaining production flow. Railroad companies donated experienced workers to production lines, understanding that building locomotives for Soviets maintained American railway expertise and manufacturing capacity for post-war competition. Labor unions agreed to no strike pledges in locomotive plants. Workers averaged 54-hour weeks. Voluntary Sunday shifts were common, paid at overtime rates. The motivation was partly patriotic, partly economic. War work paid well. It also paid regularly, unlike Depression-era unemployment that remained a vivid memory for workers in their 30s and 40s. The combination of patriotism and prosperity created productivity that Soviet observers documented but could not explain within Marxist economic theory. Soviet engineer Major Konstantin Ivanov filed monthly reports from his station at Baldwin's Philadelphia plant. His March 1942 assessment captured the ideological confusion. Americans waste materials, he wrote, but produce results. He described assembly line chaos, where workers seemed to lack overall understanding of locomotive construction. Yet these ignorant workers produced operational machines at rates exceeding Soviet Engineering Institute's theoretical maximums. His reports reached Stalin with careful language emphasizing American workers' solidarity with Soviet struggle, while avoiding direct acknowledgement that competitive capitalism was outproducing socialist planning in the category Soviet ideology claimed as communism's natural advantage: industrial production. By summer 1942, the three factories had produced over 300 locomotives. They sat in rail yards awaiting ocean transport, proof that American production was not the bottleneck. The bottleneck was loading 120-ton machines onto ships without sinking them. December 1941. Philadelphia Naval Shipyard. The first Russian decapod locomotive sat on the dock beside a Liberty ship, and maritime engineers stared at it the way men stare at problems they cannot solve. Standard cargo could be crated, broken into pieces, and packed into ships in ways that spread weight evenly. Locomotives could not be taken apart without defeating the entire purpose of rapid delivery. They had to go onto ships complete and assembled, which meant putting 120 tons of top-heavy metal onto vessels designed for distributed cargo loads. The physics were simple and unforgiving. Ships stayed upright through careful balance. Weight positioned low in the hull kept the center of gravity below the center of buoyancy. That relationship created stability. Locomotives stood 15 feet tall. Placing them on deck raised the center of gravity dramatically. A ship with 4 locomotives on deck would become top-heavy. In calm seas, this was manageable. In North Atlantic winter storms with 30-foot waves, the ship would roll excessively, possibly capsize. Insurance actuaries calculated a 40% loss rate in heavy weather. No shipping company would accept those odds. Engineers proposed laying locomotives on their sides. This was rejected immediately. The running gear, wheels, and axles would be damaged beyond repair. Removing boilers to reduce height was suggested next. This was also rejected because reassembling boilers required specialized welding and weeks of work, exactly what the Soviets could not provide. The locomotive had to arrive operational, which meant it had to travel upright and complete. Liberty ships measured 441 feet long, with cargo holds 280 feet by 57 feet. Each locomotive measured 64 feet long, 10 feet wide, and 15 feet high. The dimensions allowed multiple locomotives per ship, but only if the weight could be secured against movement. A locomotive shifting even 3 feet during a storm would alter the ship's balance catastrophically. The securing system had to be absolutely rigid while the ship flexed and rolled in heavy seas. Naval architects designed custom cradles, steel frameworks bolted directly to the ship's deck and reinforced down to the keel structure. Each cradle weighed 8 tons and was fitted precisely to the locomotive's wheelbase. 24 chains per locomotive, each rated for 50-ton loads, secured the machine to its cradle. The redundancy was intentional. Any 6 chains could hold the locomotive independently. If 18 chains failed simultaneously, the remaining 6 would still prevent movement. Wooden blocks were wedged between wheels and cradle to eliminate any microscopic shifting. Heavy tarpaulins protected against saltwater spray. Loading a single locomotive required 6 hours. Cranes lifted the 120-ton machine inches at a time, while dock crews guided it into position over the cradle. Chains were attached and tensioned in sequence, each checked twice. The positioning had to be exact. A locomotive placed 18 inches forward of optimal position would create balance problems when combined with other cargo. Weight distribution calculations were performed individually for each ship. Ballast adjustments used seawater pumped into empty holds to counterbalance deck cargo. Ships underwent stability tests before departure, heeled deliberately to 15 degrees to verify they would return to upright position. Maximum capacity per Liberty ship was 4 locomotives on deck and 2 in the forward hold. The forward hold locomotives sat lower, helping balance the deck cargo. Even with careful loading, these ships rode differently than standard cargo vessels. They rolled more slowly, a ponderous movement that sailors found unsettling. The ships were stable according to calculations, but stability felt different when 480 tons of locomotives sat above deck. The locomotives entered the convoy system, integrated into regular Murmansk runs. The route from Scotland through Iceland to Murmansk covered 2,000 miles through the most dangerous waters of the war. German U-boats hunted in wolf packs. Surface raiders like the Tirpitz threatened from Norwegian fjords. Luftwaffe bombers based in northern Norway attacked convoys within range. Ice formed on deck equipment. Storms appeared without warning. Ships travelled in formation. Speeds matched to the slowest vessel, usually around 10 knots. Journey time averaged 10 to 14 days if nothing went wrong. Convoy PQ-16 sailed in May 1942 with 35 ships, 7 carrying locomotives. German attacks began on the 3rd day. U-boats torpedoed 3 ships in the first attack wave. 1 carried locomotives. It sank in 11 minutes, taking 12 Russian decapods to the ocean floor. Luftwaffe bombers sank 4 more ships over the next 2 days. Another locomotive carrier went down with 8 machines aboard. The convoy reached Murmansk with 28 ships surviving. 4 locomotives lost meant $480,000 worth of equipment at the bottom of the Arctic Ocean. But 24 locomotives delivered meant Soviet railways gained pulling capacity they desperately needed. Convoy PQ-17 in July 1942 became a disaster that caused temporary suspension of the Murmansk route. 24 of 35 ships were sunk. No locomotives sailed with PQ-17 because intelligence had warned of exceptional German naval presence. The calculated risk became calculated avoidance. Alternative routes developed. The Pacific route through Vladivostok covered 8,000 miles but faced fewer U-boats. The Persian corridor through Iran allowed rail transport north into Soviet territory. By late 1943, 40% of locomotives traveled via Murmansk, 35% via Vladivostok, 25% via Persian Gulf routes. March 4, 1942. The SS Thomas Hartley docked at Murmansk with 4 locomotives secured on deck. Soviet dock workers gathered to watch the unloading, expecting to see disassembled components requiring months of reassembly work. When cranes lifted the first complete locomotive and placed it on Soviet tracks, confusion spread through the crowd. American merchant marine officers explained through translators that the locomotives were operational immediately. Soviet railway officials remained skeptical until an American engineer climbed into the cab 40 minutes after unloading and started the engine. Steam pressure built. Drive wheels engaged. The locomotive moved forward under its own power on Soviet gauge tracks. Pulling a test consist of empty freight cars. The official report to Moscow documented the arrival, but struggled with the implications. How to explain that capitalist production delivered what Soviet planning could not provide? The political solution was rhetorical. American workers, inspired by Soviet example and solidarity with the workers' state, had achieved production heroism. The private assessments told a different story. General Kovalev's classified report to Stalin recommended immediate study of American logistics methods. Stalin's margin note, preserved in archives, read simply, "Results matter more than methods." By summer 1942, locomotives were arriving weekly. But arrival was not operation. The next test would be whether American machines could survive Soviet winter and Soviet coal. December 1942. Arkhangelsk region, Northern Soviet Union. Temperature -43 degrees Fahrenheit. American locomotive number 3047 had been operating continuously for 72 hours without shutdown, pulling ammunition trains to forward positions, while Soviet-built locomotives sat frozen in rail yards, their boilers drained to prevent cracking, their fires extinguished because restarting in extreme cold required hours of careful heating. The American machine ran as if cold weather was irrelevant. Soviet railway operations in winter followed procedures developed through harsh experience. Boilers were drained every night because water left inside would freeze and split the metal. Fires were maintained around the clock in locomotives that had to remain operational, consuming enormous quantities of coal and requiring constant crew attendance. Special cold weather lubricants were specified but rarely available. The result was that 40% of Soviet locomotives became non-operational in deep winter, exactly when military operations demanded maximum capacity for moving supplies to troops fighting in frozen conditions. The Russian decapods had been designed specifically for these conditions by American engineers who had never experienced Soviet winter but had studied the problem systematically. Steam lines carried improved insulation that reduced heat loss by 35%, keeping water from freezing in pipes. Bearing systems were sealed against moisture intrusion that would freeze and seize mechanisms. Fireboxes were built larger to accommodate lower quality Soviet coal while maintaining adequate steam pressure. Preheating systems allowed quicker cold starts, reducing the time from dead cold to operational pressure from 6 hours to 90 minutes. Comparative performance data documented in Soviet railway records showed the gap clearly. Soviet locomotives achieved 40% operational rates in deep winter when cold disabled the rest. American locomotives maintained 87% operational rates in identical conditions. The 11-hour difference in startup time meant American locomotives could be shut down to conserve coal, then restarted when needed, while Soviet locomotives had to burn continuously or face extended downtime. Soviet railway engineer reports struggled with the language to describe this. One report stated simply that American machines do not recognize cold, a phrase that suggested the locomotives possessed agency rather than superior engineering. Stalin read these reports with his characteristic directness. His note to Commissar Kovalev asked a question that had no safe answer within Soviet ideology. Why can Americans build better Russian locomotives than Russians? The question went unanswered officially, but Soviet engineers understood the answer privately. American designers had treated Soviet specifications as engineering problems rather than production targets. They had tested solutions rather than assumed solutions. They had built machines for actual conditions rather than theoretical conditions. The coal problem demonstrated this approach. Soviet coal contained high sulfur and high ash content, producing less heat per pound than American anthracite. Standard American locomotives designed for Pennsylvania coal achieved only 60% efficiency when burning Soviet coal. Soviet domestic locomotives, designed for their own coal, achieved 71% efficiency. The Russian decapods, specifically engineered for Soviet coal conditions, achieved 82% efficiency. The Americans had studied Soviet coal samples before beginning design work. They had modified grate systems to prevent clinker buildup from high ash content. They had enlarged ash pans to accommodate 30% more residue. They had increased draft capacity to compensate for lower heat output. This level of customer-specific engineering amazed Soviet observers because it contradicted their understanding of capitalist production as purely profit-driven without concern for actual use. Maintenance presented the next challenge. American locomotives used different specifications than Soviet standard. Wrenches did not fit. Bolt threads were different. Valve types were unfamiliar. Soviet mechanics accustomed to their own machines faced a learning curve with American equipment. The American solution was comprehensive. Every locomotive batch shipped with a 2-year supply of spare parts, 847 individual items per locomotive, organized in modular kits by system. Boiler kit, running gear kit, brake kit, electrical kit. Soviet mechanics received 2-week intensive training from American engineers who had traveled with the early shipments. Maintenance manuals totaling 3,400 pages were translated into Russian with illustrations showing every procedure. Soviet adaptation followed quickly. Engineers reverse-engineered common wear items and began domestic production of spare parts. By 1944, Soviet factories were producing 60% of required parts domestically, reducing dependence on American supply lines. The American response was unexpected. Rather than protecting proprietary designs, American manufacturers encouraged copying. No patent enforcement was attempted during wartime. The strategic calculation was simple. American goal was Soviet victory over Germany, not post-war market protection. Every Soviet-made spare part that kept an American locomotive operational served American strategic interests. Performance records documented the advantage quantitatively. The Moscow-Leningrad route covered 400 miles through territory recently reclaimed from German occupation. Soviet locomotives averaged 18 hours for the journey with a 45% on-time arrival rate. American locomotives averaged 15 hours with 78% on-time rate. Freight capacity showed similar gaps. Soviet locomotives pulled maximum loads of 1,200 tons. American locomotives pulled 1,450 tons, 20% greater capacity from similar-sized machines. Fuel efficiency favored American designs by 14%, 142 pounds of coal per mile compared to 165 pounds for Soviet locomotives. Maintenance intervals revealed the reliability difference most clearly. Soviet standard practice required major service every 4,000 miles due to wear and component failure rates. American locomotives ran 6,500 miles between major services. This meant American locomotives spent more time pulling trains and less time in repair shops, effectively multiplying their contribution beyond their numerical strength. Soviet railway officials' private assessments, declassified in the 1990s after the Soviet Union's collapse, acknowledged what could not be stated publicly during the war. Marshal of Railway Troops Boris Bachevsky wrote that American locomotives saved the railway system in 1942 and 1943, when Soviet production could not meet demand. Engineer Colonel Dmitry Lvov calculated that one American locomotive equaled 1.4 Soviet locomotives in practical output when accounting for reliability, capacity, and operational time. Official Soviet publications in 1943 credited American workers' solidarity with Soviet struggle, carefully avoiding acknowledgement that American industrial methods were superior. The actual Soviet military assessment, classified until 1991, stated plainly that American industrial capacity exceeded combined European capacity, including Germany. This recognition created cognitive dissonance at the highest levels of Soviet leadership. How to accept that capitalist production could exceed socialist production in the very measures Marxist theory predicted would favor socialism. Veterans' post-war memoirs, published after Soviet ideological constraints relaxed, consistently mentioned American locomotives with respect and affection. Soviet railway soldier Anatoly Rybakov's memoir described how crews called them Amerikanskie and trusted them never to fail. The locomotives had become more than equipment. They had become evidence that Soviet ideology about capitalist weakness and inevitable socialist superiority was contradicted by physical reality delivered by ship across oceans. By 1944, American locomotives were so integrated into Soviet operations that military planners scheduled offensives based on American locomotive availability. The strategic impact extended far beyond military logistics into questions about which economic system could actually produce abundance. The mathematics of Soviet railway capacity told a story of transformation through American industrial power. In 1941, before German invasion destroyed production facilities, the Soviet Union operated 28,000 locomotives in total. This number included damaged machines and units requiring major repair. Effective operational capacity stood at approximately 16,000 locomotives capable of daily service. These machines moved 840,000 tons of freight daily and supported 420 military supply trains. By 1944, German advances and combat losses had reduced Soviet domestic locomotive inventory to 24,000 units. The difference was 2,000 American locomotives operating at 85% availability rates. Effective operational capacity had increased to 18,700 locomotives despite numerical losses. Daily freight capacity reached 1,240,000 tons. Military supply trains increased to 680 daily. The American contribution represented 10.7% of total fleet numbers, but accounted for 18% of actual freight capacity due to superior reliability and pulling power. This translated to 260 additional military supply trains daily, each carrying approximately 1,200 tons of ammunition, food, fuel, and equipment. The additional capacity totaled 312,000 tons daily, the difference between maintaining offensives and stalling for lack of supplies. Major Soviet operations correlated directly with American locomotive availability. Operation Bagration in June 1944, the massive offensive that destroyed German Army Group Center, relied on American locomotives for 40% of supply train operations. The Vistula-Oder offensive in January 1945 used American locomotives for 52% of ammunition supply transport. The locomotives were only the most visible component of American railway assistance. Lend-Lease railway equipment included 11,075 freight cars with 70-ton capacity compared to Soviet 50-ton standard. The same locomotive could pull 40% more freight when coupled to American cars. Another 1,900 specialized tanker cars transported fuel and lubricants. 120 breakdown cranes recovered derailed equipment and cleared wrecks. Railway construction materials included 622,000 tons of steel rails, enough to rebuild 2,800 miles of destroyed track. Portable bridges for railway river crossings arrived in 187 units, each capable of supporting locomotive weight across spans up to 120 feet. Communication systems modernized Soviet railway operations through American equipment. 956,700 miles of telephone wire connected dispatch centers to rail yards and junction points. 35,800 radio stations enabled train coordination across vast distances where wire communication was impractical. American railway traffic control systems introduced to Soviet operations reduced collision rates and improved scheduling efficiency. The total value of American railway equipment delivered to the Soviet Union reached $1.07 billion in 1940s dollars, equivalent to approximately $18 billion in 2025 currency. For comparison, the Manhattan Project that developed atomic weapons cost $2 billion in 1940s dollars. The United States spent half the cost of the atomic bomb just on Soviet railway infrastructure. Soviet engineers studying American locomotive production methods learned lessons that challenged fundamental assumptions about socialist industrial organization. Standardization enabled speed. 3 factories producing identical products from shared specifications achieved higher output than centralized facilities producing varied designs. Competition increased output. Rival firms racing to outproduce each other generated innovation and efficiency that planned production could not match. Quality control through testing rather than inspection caught problems before products failed in service. Worker specialization allowed rapid training and high productivity, even with inexperienced personnel. Transparent supply chains with 847 suppliers coordinating through open communication maintained material flow without central direction. Soviet post-war industrial reforms incorporated these lessons while avoiding public acknowledgement of their source. The 1946 to 1950 5-year plan emphasized standardization across industries. Locomotive plants were reorganized using assembly line principles observed at American factories. Quality testing protocols modeled on American practice replaced inspection-based approaches. The ideological problem was inescapable. Crediting capitalism was politically impossible. The solution was rhetorical gymnastics. Soviet publications credited advanced American workers rather than American economic systems. Private military assessments told different stories. A 1944 General Staff report stated that American productive capacity could not be matched through socialist organization alone. Khrushchev's private notes from 1943 acknowledged that Soviet planners must learn American methods without adopting American ideology. The irony was documented in archives opened after Soviet collapse. The Soviet Union defeated Germany using American tools while maintaining public propaganda about socialist superiority. Soviet locomotive crews developed personal relationships with their American machines. They gave them nicknames: Amerikanskie Towarzysze, American comrades. Crews competed for assignments on American locomotives, which were considered more reliable and easier to operate. Cultural artifacts emerged. Crews personalized locomotives with painted names. Locomotive 2847 was named Roosevelt by its crew and operated until 1953, 8 years after the war ended. American merchant marine sailors who delivered the locomotives paid a price rarely acknowledged. 243 merchant ships carrying railway equipment sailed to the Soviet Union through submarine-infested waters. 87 American sailors died in U-boat attacks and storms while delivering locomotives to an ideological enemy. The Soviet government awarded 34 American sailors the Order of the Patriotic War, marking the first time Soviet decorations were given to Americans. The recognition was genuine but limited. Most sailors who died in convoy service received no acknowledgement beyond their names on casualty lists. Post-war fate of American locomotives demonstrated their durability. They remained in Soviet service through the mid-1950s. Some were transferred to Eastern Bloc nations, Poland and Czechoslovakia, where they continued operations into the 1960s. Final retirement came as diesel locomotives replaced steam across Soviet railways. 14 Russian decapods were preserved in railway museums across Russia. Museum plaques credit fraternal assistance from American people, carefully avoiding mention of capitalist production methods that made delivery possible. The locomotives became artifacts of a cooperation. Both sides had ideological reasons to minimize after the war ended. The human element of Soviet-American railway cooperation survived in memories more than official histories. Soviet veterans interviewed decades later consistently identified American locomotives as crucial to victory. They remembered the machines as reliable, powerful, and somehow different from Soviet equipment in ways that suggested a different approach to manufacturing. The locomotives represented something neither Soviet propaganda nor American Cold War narratives wanted to emphasize: that opposing systems could cooperate when survival demanded it, and that cooperation revealed uncomfortable truths about which system actually produced abundance. By 1944, American locomotives had become so integrated into Soviet operations that they were simply part of the railway system, their foreign origin notable only in their superior performance. The amazement Soviet generals felt when complete locomotives arrived by ship had transformed into dependency on American industrial capacity to sustain Soviet military operations. That dependency would shape post-war Soviet industrial policy and Cold War competition in ways neither side fully anticipated when the first locomotive rolled off a Liberty ship onto Murmansk docks in 1942. Victory Day 1945 brought public acknowledgement of American assistance. Soviet speeches mentioned Allied contributions. Locomotive crews were interviewed for propaganda films showing international worker solidarity. Photographs of American locomotives in Soviet service appeared in newspapers and magazines. The narrative was carefully constructed. American workers, inspired by Soviet example, had achieved production heroism in support of the workers' state. The locomotives were gifts from the American proletariat to their Soviet brothers, evidence of international class consciousness overcoming capitalist attempts to prevent cooperation. This narrative lasted 2 years. By 1947, Stalin's post-war nationalism demanded that Soviet victory be portrayed as entirely Soviet achievement. References to Lend-Lease began disappearing from official histories. Museum exhibits were altered. American locomotives were relabeled as Soviet production or left without identification. Locomotive 2847, named Roosevelt by its crew during the war, had its name painted over and was renamed Stalin. Railway workers were warned that excessive discussion of American equipment could be interpreted as lack of appreciation for Soviet achievements. Veterans who mentioned American help in public settings sometimes faced political suspicion and questioning. The Cold War intensified the erasure. Soviet history textbooks published from the 1950s through the 1980s made no mention of 2,000 American locomotives delivered by ship. Students learned that Soviet industry had provided all equipment necessary for victory. Railway museum displays showed Soviet-built steam locomotives without acknowledging that many were American designs. The suppression was so thorough that generations of Soviet citizens grew up unaware that their railway system had depended on American production during the war. The West participated in parallel forgetting. American public attention focused on the Western Front and Pacific campaigns. The locomotive program appeared in few popular histories. When mentioned at all, it was treated as technical detail rather than strategic contribution. The fact that American industrial capacity had sustained Soviet military operations while simultaneously supporting operations in Europe and the Pacific was lost in Cold War narratives that emphasized ideological conflict rather than wartime cooperation. The 1980s brought glasnost and partial opening of Soviet archives. Historians discovered the extent of Lend-Lease railway assistance. Declassified Soviet military reports showed American contribution was crucial to maintaining operations during critical periods. Russian historians published revised accounts in the 1990s after the Soviet Union's collapse. These studies acknowledged that Eastern Front victory had depended significantly on American logistics support. Specific credit was given to the locomotive program for maintaining supply lines when Soviet production could not meet demand. Russian veterans finally spoke openly in interviews published after decades of required silence. Locomotive crews held reunions that included tributes to the Amerikanskia machines they had operated. Railway museum exhibits were restored to show accurate history, including American locomotives' role in Soviet victory. American historians rediscovered the program through these Soviet revelations. Albert Weeks's comprehensive study of Lend-Lease, published in 2004, examined railway equipment transfers in detail. Academic recognition followed an industrial achievement that had been hiding in plain sight within shipping manifests and production records. The locomotive program revealed capabilities of democratic capitalism that contradicted assumptions both sides had maintained during the Cold War. Speed from design to delivery in 6 months demonstrated that democratic systems could mobilize rapidly when necessity demanded. Scale of 2,000 complex machines in 3 years showed that market competition could achieve production volumes matching or exceeding centralized planning. Coordination among 847 suppliers and 3 factories producing identical products proved that distributed decision-making could maintain quality and efficiency without central control. Innovation emerged from competition rather than directive, as each factory sought advantages over rivals. Flexibility allowed adaptation to customer specifications, with American engineers designing for Soviet gauge and Soviet coal without requiring Soviet methods. Transparency welcomed Soviet observers and shared methods openly, demonstrating confidence rather than secrecy. The generosity of providing spare parts, training, and technical support without patent protection showed strategic thinking beyond immediate profit. Soviet recognition came privately through classified reports now available in archives. Centralized planning could not match competitive production rates. Quality control through testing proved superior to quality control through inspection. Innovation emerged from competition more reliably than from planning directives. Worker motivation responded to market incentives more effectively than to ideological appeals. These conclusions were documented in internal assessments, but could never be acknowledged publicly without undermining the entire basis of Soviet ideology. The uncomfortable truth affected both sides differently. Soviets needed capitalist production methods to survive the war. Their ideology said they should win through socialist superiority. Americans helped a communist system prevail over fascism, supporting an ideological enemy that would become the primary adversary within 2 years of victory. Post-war implications shaped the Cold War arms race as both sides applied lessons from the locomotive program. Soviet industrial reforms copied American methods while denying the source. American strategic planners recognized that logistical capacity mattered as much as weapons technology. The competition became a race to demonstrate which system could manufacture more, faster, and better. Modern parallels emerged in the 2020s as global supply chain vulnerabilities exposed during pandemic and conflict raised questions the locomotive program had answered 8 decades earlier. Can democracies mobilize industrial capacity quickly when threatened? The locomotive program demonstrated 6-month timelines from design to production when necessity eliminated peacetime bureaucracy. Is industrial capacity still decisive in modern warfare? Precision weapons mean nothing without production volume to sustain operations, as artillery consumption rates in recent conflicts have proven. Can allies rely on American production capacity? The 1940s showed America could equip allies while fighting globally, but 2020's production capacity raised concerns about whether that capability still existed. What does mobilization require in modern context? The 1940s relied on redundant capacity, standardization, and domestic supply chains. The 2020s featured just-in-time production, specialized global suppliers, and efficiency prioritized over resilience. The locomotive program suggested that rapid mobilization required deliberate maintenance of excess capacity and domestic production capability that peacetime economics considered wasteful. The general's amazement at American locomotives delivered by ship was never really about the locomotives themselves. It was about what those locomotives represented. industrial capacity as weapon, cooperation between opposed ideologies, logistics determining victory, democratic production methods outperforming authoritarian planning. The delivery was routine, systematic, sustainable. 2000 was considered achievable rather than exceptional. The impossible had been made boring through sheer capability. Soviet General Kovalev's post-war memoir, published posthumously in 1965, captured the recognition that could not be stated during his lifetime. We thought Americans soft, incapable of sacrifice or organization. They proved capable of both through methods we could not replicate. The locomotives arrived not as gifts but as demonstrations. Demonstrations that their system, chaotic as it appeared, produced results our system, organized as it was, could not match. The final locomotive preserved in the Russian Railway Museum in St. Petersburg carries a placard reading American Locomotive, Lend-Lease Program, 1942. Visitors rarely stop to read the description. School groups walk past toward more dramatic exhibits featuring Soviet achievements. But historians recognize what the 120-ton machine represents. The moment Soviet generals learned that abundance, not ideology, wins wars. That market competition could defeat central planning. That the impossible request could become routine delivery. The American locomotives delivered by ship carried more than freight. They carried proof that democracy could outproduce dictatorship, and that realization would shape the remainder of the 20th century as both systems competed to demonstrate which could sustain the abundance those locomotives represented. Soviet generals were amazed not by engineering, but by the revelation that their entire worldview had been built on assumptions about capitalist weakness that 2000 locomotives conclusively disproved.